This is going to be a quick run through of the internal assessment criteria. So basically what you're going to be marked on for the internal assessment in 2016. Okay, the criteria are these. They're personal engagement, worth 2%. Exploration is worth 6. Sorry, not 2%, 2 marks. 6 marks for exploration, 6 for analysis, 6 for evaluation, 4 for communication, and that gives a total of 24 marks, which will be scaled down to 20% of your full mark for physics. The first criterion is personal engagement. This is a new criterion, and it basically is meant to show how engaged you are with the investigation that you're doing. So this is both in the process, and obviously it's going to be important then that you communicate this engagement in your report clearly. So you need to kind of have a tone of sort of enthusiasm and interest throughout your report as you're writing your report, which you will if you are enthusiastic and interested about the topic that you've chosen. Also, if you show innovative or creative ways of approaching the problem that you've got, that'll help contribute to your personal engagement mark, which is a total of 8% of your final mark. The exploration section is the first big section. This is basically the planning of your investigation. You need to come up with a clear, focused research question, which is like an aim. So in the experiment that we did earlier this year, the research question would have been, how does changing the mass suspended from a vertical spring affect the time period measured for one complete oscillation? So that's a focused research question that has there's a very clear way to answer that research question through an experiment. So that's the first part. The second part is to do a bit of research and find out some of the background information to the physics behind what you're working on. And so that will involve you going into your textbooks and various other sources online, probably, or databases, and then summarizing a little bit about the physics behind the investigation that you're undertaking. And you'll need to remember to cite all the sources that you use for this section. Thirdly, you need to have a clear method, and that's a method that takes measures to reduce uncertainties, to make your investigation accurate, to make it reliable. So repeating measurements where you suspect there's a large random uncertainty and taking averages, for example. Making sure that your investigation is fair by controlling all of the key variables that need to be controlled. There needs to be evidence of all of these things, that you've taken steps to do all of these things in your method. Finally, you need to also take into account any safety, ethical, and environmental issues, and there may or may not be those in the investigation that you decide to do. But if there are any of those issues, you need to make sure that you've accounted for those in your report. So that section is worth 25%. It's basically your whole plan for the investigation. The analysis of your results is worth 25%. So that firstly includes including a full table of all of your data that you collected in the experiment. And that will provide evidence that you have sufficient data to back up all of the analysis that you undertake. So there needs to be a complete data table included. Secondly, all of the processing of the data needs to be carried out accurately. And that doesn't just mean that you got the correct answers, it also means that you've shown the method by which you arrived at those answers by including a sample calculation for each bit of data processing that you've carried out. And all of that data processing, so that includes things like repeating and averaging, and of determining the uncertainties in your raw values and propagating those uncertainties to your processed values. So if you square a variable, for example, then you also need to propagate the uncertainty in that variable correctly so that you end up with the correct accounting for uncertainties. So all of that processing you need to have done accurately, and you need to have shown that you have done it accurately. Thirdly, you need to in your graphs, you need to include error bars to account for all of your uncertainty, and in your equations that you obtain from your graphs, you need to include all of your uncertainties. And this should be a fair accounting of uncertainties. So if you had a very large uncertainty in a measurement, then the uncertainty should be large in all of your values as well. Otherwise, you'll end up with results that are very difficult to interpret, and you'll end up losing marks for the analysis section. Finally, you need to use your graph to extract an equation. Usually, that's how we process the data and interpret it. And that equation that you extract from the graph is what you're going to base your conclusion on. Okay, and then there's the evaluation section, which is another 25%. So that firstly is the conclusion that you've derived from your data that you've analyzed, and that conclusion should fully answer the research question, and it should draw on the experimental data that you obtained in order to do so. You also need to describe your conclusion. So usually that will involve describing the equation that you obtained from your graph and what it means, and you can compare that to what physics theory would predict. So this might relate back to that background section that you had in the beginning of your experiment. If there's some known constant, like the acceleration due to gravity, for example, that comes out of your analysis, then you should be able to compare what you found in your experiment to what theory predicts should be the value for that. Or if you've done an experiment where you've got a value for a gradient which should relate to certain quantities, then you should be able to compare those to what science theory predicts those quantities should be. And then in your evaluation, you also need to look at what worked well and what worked less well in your investigation. So if you came up with a very innovative way to measure something and you feel like it worked really well and dramatically reduced the uncertainties, this would be a place to discuss that. It would also be a place to discuss kind of areas where you had difficulty making accurate measurements, and looking at ways in which you might, in a further experiment, reduce the uncertainties that you got in those variables. So you should discuss both the strengths and weaknesses, and discuss kind of the impact that those strengths and weaknesses had on your experiment. A convenient way to do that is kind of to create a sort of table where you list all the strengths and list all the weaknesses, and then talk about their impact on the experiment, and then go on to do this last point, which is discussing how you might improve on the things that you identified as being weaknesses. Finally, you need to, the last section is communication, and that's basically if you're being clear, concise, your report is well structured, you're writing, you communicate your ideas clearly using the correct physics terminology. And this section is worth quite a lot. It's worth 17%, and your mark for this will dramatically improve if you submit a carefully crafted draft so that your teacher can give you feedback on the specific points where you're losing marks on communication. So they'll be able to identify errors that you need to work on and so forth. So that's the last of the criteria. So if you have any questions about those, or if it's not clear about what any one of those things implies, just let me know. And you can review this video as you're writing your report to ensure that you've kind of met all of the criteria. Cool. Let me know if you have any questions.